You are welcome. You are welcome to Rosie Math class today. I am so excited to meet you again. Today's lesson is continuation of our circle theorems. So we'll go on with circle theorems. Let's go. So we look at inscribed angle of a semicircle. Okay, I have a circle here divided into two equal parts. If you divide a circle into two equal parts, you have semicircles, okay? You have semicircles, and here I have an angle formed by this semicircle, inscribed angle formed by this semicircle. Okay, the line that divides the circle into two equal parts is called diameter. Okay, this inscribed angle is formed at C. The inscribed angle is formed at C here, okay? And the line that divides the circle into two equal parts is the diameter AB, Okay, here is the center, okay? So this is where the inscribed angle of this semicircle is formed. Okay, we'll go on. An inscribed angle formed by a semicircle is a right angle. An inscribed angle formed by a semicircle is a right angle. Right angle means is 90 degrees. Okay, so the angle formed by this semicircle, the inscribed angle formed by this semicircle, that is the angle formed here, is a right angle, angle 90 degrees. Okay, is angle 90 degrees. So note that inscribed angle formed by a semicircle, okay, is what? A right angle. That is angle 90 degrees. So whenever you're asked an inscribed angle formed by a semicircle, just tell whoever that is asking you that it is a right angle, and when it's right angle, it means it is angle 90 degrees. Is that okay? Okay, here I have an example. You can see, okay, we have a circle, and then the circle divided into two equal parts by this diameter, and then an inscribed angle is formed here. Then an angle is also formed here, angle 50 degrees, and then another angle here, y, and this is what the one we are asked to find y. Okay, now in my previous video I explained the relationship between these side angles and the inscribed angle, and I said that the sum of these side angles is equal to the inscribed angle. So we are going to use it here. Now automatically this inscribed angle here is angle 90 because it is formed by a semicircle. And remember that twice the inscribed angle is equal to the angle at the center. Now if you watch this center, now is a straight line, and sum of angles on a straight line is 180 degrees. So that is another thing also you can take home from this. So here is 90. 2 times 90 is 180. That is to say that angle at this center is what? 180. But to go to what we have today, we are looking for y. Okay, we have to find y. How do we find y? Knowing that here is 90 degrees will help us solve this y. So let's go. Okay, so here I have already solved it. Let me explain how it's solved. Okay, so y plus 50 degrees, that is what I have here. This y plus 50 degrees is equal to 90 degrees, inscribed angle of a semicircle. Okay, y plus 50 degrees is equal to 90 degrees, inscribed angle of a semicircle. So you make y the subject and then carry this over to this side, or you subtract 50 from both sides. So we have it y now, and then this will now be 90 degrees minus 50 degrees, giving us 40 degrees. So this y is 40 degrees. Y is 40 degrees. So here is 40. Okay. So y is 40 degrees. That is solved. Okay, so you can try that yourself and you get the same answer. Okay, next we have is centric quadrilateral. Centric quadrilateral. So here I have my circle and I have a quadrilateral inside it. My quadrilateral is quadrilateral A, B, C, D. Okay, centric quadrilateral. What does that mean? Centric quadrilateral is a quadrilateral that is inscribed in a circle. A quadrilateral that is inscribed in a circle. And the theorem involved with that is that the sum of opposite angles of a centric quadrilateral is supplementary. Supplementary means is equal to 180 degrees. So this is it. So let me explain that angle at A, the angle at A, that is angle here, is opposite to angle at C. So if I take the sum, is equal to 180 degrees. And the angle at B is opposite to angle at D. If I take the sum, is equal to 180 degrees. So that is to say, angle at A plus angle at C is 180 degrees. Okay, and angle at, let me change the ink, the angle at B plus the angle at D is equal to 180 degrees. So that is what the theorem states, that the sum of opposite angles of a centric quadrilateral is supplementary, meaning that if you sum them, you have 180 degrees. So we're going to apply that in solving a problem now. Okay, let's look at example number 1. We have a quadrilateral inscribed in a circle and two angles are marked. I have the first angle 2q plus 10 degrees and then the second angle q plus 80 degrees. We have to find q. Okay, it's already solved. Let me explain what I did here. Okay, so here is q plus 80 degrees and is opposite to 2q plus 10 degrees. So you can see it here, and is equal to 180 degrees because opposite angles of centric quadrilateral is 180 degrees. So gather the like terms, and then we have 3q plus 90 degrees equals 180 degrees. Subtract 90 from both sides and we have q to be 30 degrees. Okay, so that is the answer. So try it and drop your comments. Thank you. Okay, here I have my second example and I want you to pay attention to this very well. So I have my quadrilateral inscribed in a circle and the quadrilateral is quadrilateral ABCD. Okay, ABCD, and then I have two triangles in that quadrilateral. Okay, so I have two triangles. Let me explain the diagram. Okay, I have triangle ABC and triangle ACD in the quadrilateral ABCD. Okay, and triangle ACD is an isosceles triangle, meaning that the base angles are equal. So here will also be 30 degrees. I am to find angles lobered M and N. Angles lobered M and N. So let me show you how to find the angles now. Okay, it's already solved, so let me explain how I solved it. Okay, so because triangle ACD is an isosceles, the angle here is also 30 degrees. Okay, base angles are equal. Okay, so since the base angles are equal, here is 30 degrees, and that means that to find M, I'll get this angle here and this angle here. They are opposite. So remember the centric quadrilateral, the opposite angles will sum to give us 180 degrees. So I have 50 plus 30 plus 30 plus M degrees, and that is equal to 180 degrees. Opposite angles of a centric quadrilateral. So collect like terms and I'll have 110 plus M equals 180 degrees. So make M the subject and you have your answer to be 70 degrees. Okay, so here is 70 degrees. So if I add it, it means that the angle at C of this quadrilateral is 100 here and then 80 here. Okay, so next is to find n. Okay, to find n. So for us to find n, let me get my pointer. So to find n, this is n. So what I will do is either I find D, then use the opposite angles of a centric quadrilateral, or I will work with the triangle ABC, which is what I did actually. I used triangle ABC. So knowing now that our M is 70 degrees, okay, here is already 70 degrees. So let me write it out. So here is 70 degrees. I will use it to work this out. So this is what I did. M plus 50 degrees is 180 degrees. Angles in a triangle. So M plus N plus M is 180 degrees. Sum of angles in a triangle. Then since we are looking for since we are looking for N, so I'll make N the subject of the formula, and then take the other ones, I'll subtract from both sides. So I have minus 50 here, minus N. And because we know M to be 70, I'll substitute for that and then work it out, do the arithmetic, and I get my N to be 60 degrees. So I want you to try the same, okay? So our M is 70 degrees, our N is 60 degrees. So that's another way you can apply the centric quadrilateral theorem, okay? So once you know that the opposite angles of a centric quadrilateral sum up to 180 degrees, it helps you a lot. So whether you have triangles in between or all that, you can still do the arithmetic and get what you're looking for. So I believe this video has helped you a lot. Make your comment, drop your comments down below, and like the video, subscribe as well so you get notification whenever new video is released in this channel. So thanks for listening, and God bless you so much. Bye.